Now we have to find the sum of integral multiples. Now, when you have a question worded like this, you need to see it carefully, what it actually requires. The question says to find the sum of all the integral multiples of 3 between 4 and 97. So the integral multiples of 3, that is basically a sequence or a progression, an arithmetic progression with a common difference of 3, because obviously the multiples of 3 are 3, 6, 9, 12, and so forth. And obviously they have a common difference of, all of them have common difference of 3. So the common difference is 3 between 4 and 97. And it says here that the sum of all of the integral multiples. So that means basically the sum of all of these. What does that basically mean? It obviously means that it is a series. And it says the multiples between 4 and 97. 3 is less than 4, so obviously that is not a part of it. So the first term between 4 and 97, that is a multiple of 3, is 6. So A1 will be 6 over here. See here? And the last number before 97, that is a multiple of 3, is 96. So 96 is the last number. So 6 here is A1, and 96 here is the last number. It's basically AN. Okay? So A1 is 6, the difference is 3, and 96 is AN. We have to find N. Well, we know this formula. AN is equal to A1 plus N minus 1 into D. Put in all these values, and you get the value of N as 31. So 96 is the 31st term in this arithmetic progression. Now we have to find the series. Remember this formula? Well, just plug in the values that you found earlier. So N was 31, A1 was 6, N was 31, obviously, and the common difference was 3. And when you calculate all of this, you find out that the sum of all the integral multiples of 3 between 4 and 97 is 1581. And so that is what you get.